Hey guys, welcome back. So today's topic is around idle air valve control. In the last article we did around setting up your idle, we talked about the throttle body. So we've talked a little bit about the basics of idle spark and sort of how the throttle body itself contributes to idling, but we didn't really get into the details of how the idle air control valve functions, and this is really critical both to maintain a good idle and to also, on a stick shift car, keep the RPMs from dropping too fast when you hit the clutch and you want to coast to a stop. So this is a really critical piece of tuning, and there's some things that are a little bit difficult to understand about it. So I'm hoping that this will be really a good video for you guys to go through. So first thing is, well, what's an idle air valve? So the idle air valve is something that the computer has the ability to control that allows extra air to come around the throttle body and into the engine anyways. So the computer uses that when it's, it recognizes things are going to stall or you're just not maintaining the desired RPMs at idle. It can let some additional air through, which ultimately means you're going to get some extra fuel along with it, and it can lift the RPMs back up. So really controlling this and controlling your spark are the two things the computer can try to do to maintain a steady idle and keep things happy. So this is the idle air valve, and the idea is that this is bolted to the front of your throttle body, and this is kind of where that looks like in your engine. And based on those two holes, you can see that's essentially how things are coming in through your normal intake tube, going around the throttle body and into the engine anyways, even if the throttle is essentially closed. Okay, so that's basically what the idle air valve is. Now, to go into the tune, the first thing I want to talk to you guys about is the transfer function, and talk a little bit about the quantity of air that this thing can even allow into the motor. So this is kind of like you would think of as like your fuel pump or your injectors, in that it has a duty cycle. It can open up all the way, it's at 100% duty. When it closes that valve all the way, it's at 0% duty. And the computer has a map in here, and under this idle category, idle ISC, and you go to this ISC transfer, this is basically the function that shows you at a given duty cycle how much actual air is this valve allowing into the motor. And this is separate from whatever's going to get slipped through the throttle blade, which might be slightly cracked open anyways. This is in addition to that. But this is basically saying at a given duty cycle, how much air does this thing flow? Now, one of the things we need to talk about here is, well, how much air is that really? And you notice this is measured in pounds per minute. So when you think about how much total air can, we'll start with just a bone stock 5.0, how much air can it really get through the engine? And so if we jump over real quick to our MAF transfer, this is measured in kilograms per hour, and you can see that this thing is pegged out at 835. And realistically, a bone stock engine won't get to 835. They always have to have a little bit of room because you don't want to ever max this out all the way. So this is actually more realistically where a bone stock engine is going to get you to, about 700 kilograms per hour of air at maximum power. So what I want to show you is, well, how much can get through the idle air valve? Now that you sort of understand this is the potential of a stock motor with no power adders, no bolt-ons, just stock, how much extra air is the idle air valve able to help get around that throttle body? So I want to show you a converter here. So if I go back to the ISC transfer function, and you see that this at 100% duty cycle is 2.35 pounds per minute, you can go up here in binary editor to settings and conversions, and you can convert pounds per minute to kilograms per hour, just so we can level set here. So what I can do is tell it that I want to convert something that's measured in pounds per minute. I'm going to convert that to kilograms per hour, and I want to put in our maximum airflow from this valve, which is 2.35 pounds per minute. We convert that, and that is about 64 kilograms per hour. Now I want you to think about that for a minute. So if a stock engine can get a total of about, we'll say 700, maybe a hair less, then this is roughly 10%, maybe a little bit less than that, but this valve can let about 10% of the air that motor needs at its maximum potential at red line or wherever it makes peak power, probably a little before red line. This kind of gives you an idea that this lets about 10% of that through. And if you think about how much air do you need to idle at a much lower RPM, well, you idle at 672 from the factory, very low number of RPMs. So, there's some math in here that starts to make sense that, for a given amount of RPM, given the displacement of your engine and its efficiency and everything else, there's only so much you need this valve to do. So anyways, wanted to kind of show you what this looks like. So maximum potential of this valve when it's all the way open is 64 kilograms an hour. And when it's basically at kind of its last area that it's able to control down here, it's practically nothing. So 0.12 comes out to about 3.2 kilograms an hour, so almost nothing. So I wanted to show you this transfer function first. And the other thing I want to say about this is while you can change these numbers in the tune, you shouldn't. This is something that there's no power to be gained by changing this part. It's basically it either works or it doesn't. If it's out, you replace it. But they should all be about the same. And even the aftermarket stuff should be very, very, very close to these numbers. So it's unlikely you'll ever have to do this. Now, I have seen a hack, and I've actually done it myself too, that when you get into the very bottom of this, there's a trick you can do here sometimes as kind of a last resort to try to keep things from dying on you. But it's almost never really needed, and it's something I've learned better ways since. So first thing I want to tell you is this is the transfer function. Just understand that's what it is. Don't mess with it. Okay. Now that you understand that, the next thing I want to talk about is how much air does your engine need when you're at idle, total, so that it can be happy and maintain your RPMs. Now, in the last video, you remember that we showed you here under this new base and DR base, the factory, 5-speed 5.0 idled at 672. This is its desired RPM when it's at idle. And so the question becomes, well, how much air does the engine need coming in to maintain that on a stock engine? And so you'll see that represented in this table here. So this table is basically saying at a given RPM, and there's kind of, you can plug in whatever numbers you want here, but at a given RPM, here's how much total air the engine needs coming in to maintain that. Again, assumes bone stock engine, which you guys probably don't have anymore, but that's what a bone stock engine wanted. And something very specific I want you to notice is that, remember, the computer wants to maintain 672 because that's where you've set the RPMs at. It's no coincidence that when you go to this table, there's a specific measurement of how much air is needed at that exact RPM. So this is one of the things you'll need to pay attention to later if you've changed a cam, whatever, and you want to raise up your idle RPM so that it's a little happier with a lumpy cam, which is normal. This is one of the weird things people don't remember or know about, that you have to go in and adjust this too. So like, just as a rule of thumb, if you set your idle, you want to idle at 800 RPMs, you should expect to have an entry in here at 800 RPMs, and you'll have to do some measurements to know what the airflow should be there. But you always want to set one of these values at exactly wherever you're idling. That's how the factory did it. There's a specific reason, because it's easy to measure that exact RPM and figure out what you need later. We'll cover that in another video. I'm just really right now showing you how this stuff works. So that's at 672. And the other thing I want you to notice is this has a curve to it. And you notice it goes way past your idle RPMs. And the reason is, even when you're cruising or you're driving and maybe you're at 2,000 or 2,500 RPMs and you go ahead and clutch and just coast in neutral and you let your foot completely off the gas. Well, when you take your foot off the gas completely, the engine's still technically at a couple thousand RPMs, and it needs more air to be able to sort of gracefully stay where it's at and then slowly come down in RPMs. So that's why this function here also tells you that when you're at a much higher RPM in neutral, you still need about a certain amount of air to kind of maintain where you're at. So that's why this isn't just a single number that says at the idle RPM, what do you need? That's why it's a table that can go up from there. Okay, so that's your neutral idle air. And then there's also technically another thing in here for your drive idle air. So when your car's in drive, how much air does it need? But because this is built around an A9L, T5, 5-speed Fox Body setup, these numbers are basically the same. So if you look at the curve here for this function when you're in neutral, you notice that when you're in drive, it's almost identical. There's a hair difference in this mid-range, but it is almost exactly the same, including having an entry at whatever your RPMs are desired to be at idle, and that has the exact same value here. And when you get up to the top of what it showed in that table, this number's about the same. And on the drive, they put a little bit more detail in here, but generally what you'll do with a 5-speed car is you'll focus on this table, figure out where these numbers need to be happy, and then you'll just copy this exact setting over to your drive. They'll be the same and everything will be fine. So that's basically the basics of how this thing functions. Now, the other thing that you need to know is that when you first start up the car, all of this stuff goes out the window, And just like your fuel, your car, while you're cranking, it's not reading the mass air meter to understand how much air is coming in and how much fuel to add to make it happy. The car has to be running on its own before it starts to read the mass air transfer. So this is the exact same way as your fuel. While you're cranking the engine, it is actually letting some additional air come through around the throttle body and into here. And that's based on what temperature your engine's at while you're cranking it. So you notice that when you're kind of doing a hot start and you're at full, 180 coolant temp or higher, it starts to bring that idle air duty cycle down. So it's still letting a lot of extra air come through. It's at 60% duty cycle here, but it needs that extra air, and it's kind of hard coded in here. And then once the car catches and it turns over, then it goes into its normal idle air control. So just understand that this is basically the main thing you'll have to tune to focus on your cranking. So if you figure out you can't get the car to start when it's cold or hot or whatever, it's going to come down to your injector size, your cranking fuel setup, and this air setup. And you're going to have to manually balance the air to fuel, and this is where the air portion of that comes in. Okay, so that's the basics there. The other thing I want to talk about is what happens when you're potentially stalling. So we know that you're trying to target 672 RPMs, but again, maybe you clutch, something came down too fast and it starts to dip under that. So we've already looked at the spark table and kind of how that happens in the others. So it knows that when you start to stall or you go too low below your desired, it'll add some additional timing to try to pep it back up and keep it happy. And then if for some reason it goes over that and you're idling too high, it'll pull a little bit of timing. And so there's a spark balance that's trying to, raise or lower the spark to try to maintain that steady state. Your idle air valve's the exact same way. And there's two different things in here that affect that. So one is this adder right here. So we already know in general how much air do we need to be happy. It's some various RPMs, but mainly this is the one that's critical. But what happens if we dip down to 500 RPMs or 400 or something and it's about to stall out? Well, there's an adder right here that's basically saying, in this case, it starts to kick in at 600 RPMs or less, and as it starts to get lower and lower, this number increases, and this is basically an additional amount of air that the computer's going to ask that idle air valve to give us. So it's, regardless of what your neutral set to and all that, this is going to kick in. So again, if you're targeting 672 from the factory, it starts to think underspeed in this case is about 600, and that's when it starts to give you a little bit more air and fuel to try to pep the motor back up again. So again, if you raise your desired RPM to 800 or 900, whatever you set it to, this is another place that you need to raise accordingly. And you have to think about that, because if you're now asking it for, let's say, 1,000 RPM, something dramatically different, well, if you're going to wait all the way until it gets to 6 to start thinking maybe it's stalling and react to it, it's already too late. It's already gone so far below desired, it probably can't catch it, and it's going to go ahead and conk out on you. So this is important to think about too, that you'll need to tune this appropriately, but we'll get more into the details of that in another video. Now, a second way that the computer compensates this idle air when it thinks you're stalling or you're idling too high, there's also a gain that it adjusts. And so let me find the gain in here. There we go. So you notice that when we're in the sweet spot where we're happy and we're between 688 and 656, 672 is basically right in the middle of that it's saying just to do exactly what you normally do. 100% of whatever we're normally asking for, leave it alone, that's fine. But you notice that it's asking for it to react quicker when you go below 656 or above 688. And this is basically saying how fast is it transitioning in that extra air, or taking less or subtracting some air to try to maintain your steady state. And so there's this big V-shaped curve here that, again, it starts to freak out when you get really low, and it wants it to react a lot faster to try to pep it up. And when it starts to go over speed, it reacts a lot faster and tries to bring it down. And this is another one of these places where if you start having a really drastic swinging idle, but your fuel's pretty close to dialed in, this is probably one of the culprits. You might lower these numbers here, so like the 3 and the about 4 down here. You might try lowering these down so the gain isn't trying to react quite as fast, and it's trying to react closer to kind of normal. Because again, there's also spark doing the same thing. So you throw a bunch of extra spark, you way overreact, and you add a bunch of air, and you try to stuff the air in real fast, and next thing you know, it's swinging, and it's going back and forth and back and forth. And usually every swing, it goes a little further than where it was the last time. So, eventually the car's going to die, or you're going to have to put your foot in it or whatever and try to keep it happy again. So that's that. Now, there's one last topic I want to cover just about the basics of how this works. And I'm going to go back to this neutral idle air table for a minute. So remember, we're asking from a factory, we want 672 RPMs, and we know that according to this, that's how much airflow we need coming into the engine to maintain that. And the thing is though, your throttle blade is never fully closed. There's always some air that leaks through the actual throttle blade, even when your foot's off of it. And that's what that idle set screw is for, that when you're opening and closing that, you're cracking the throttle blade open. So one of the things you need to understand about your engine is based on however you've set that screw. And let me just jump over here real quick so you guys know what I'm talking about. This is your throttle body, and that's that set screw. Yours might look a little different, but you increase or lower this, and it's going to slip the blade open just a hair. So some air is going to get through even if the idle air valve is closed. So what you have to understand to get this right is you need to know, well, based on where you set that throttle stop screw, how much air is getting through the motor that way. Then we can take a look at, well, how much total did we want? And we know that whatever the total is, minus however much is getting through the throttle body already, that's how much extra the idle air valve is going to have to give you. And so the way we can see this is right up here. So your throttle body airflow. So what this is a measurement of is if you pretended like you didn't have an idle air valve, and you were just trying to measure how much air is getting through the throttle body itself when I'm completely off of it, this is what the factory says, 0.55 pounds per minute. So think about that. If at neutral, I need 0.75 pounds per minute total getting into the engine, but then I come up here and I also know that 0.55 of that is already going to get through the throttle body, then what that means is I can do the math and subtract that. So I'd have 0.75 total that we need minus the 0.55 that's already getting through the throttle body. And now I know that the idle air valve to maintain RPMs is going to have to provide an additional 0.2 pounds per minute of air. And so if you think about, well, where is that on that transfer function, 0.2 pounds of air, what duty cycle is that going to put this at? Well, that's going to be kind of somewhere between here and here. So somewhere between 28% duty cycle and 39% duty cycle. And that's about where this thing would have to kick in to make things happy. So when we talked about in the last video that you generally are trying to set that idle screw on your throttle body so that you're somewhere between like 20 and 35% duty cycle on your idle air and everything's happy. Well, this is where that logic, that thought process came from. This isn't just like random stuff that people thought up. That's how the factory did it. So now, again, your throttle body could be totally different. Your engine's totally different. The amount of air you need, everything else could be different, but this is still a fundamentally sound approach. So in a future video, when we start to really talk about how to set all of these settings to get your idle right, this is a big thing that we're going to have to talk about is how do you figure out with your configuration how much air do you actually need to make the motor happy? That's the first thing you got to figure out. Then you figure out, okay, and how much of that do I need to get through the throttle body? So how far do I need to open that to get a decent amount of air through? And then the last piece is then how much needs to go through my idle air valve. And that's really the tuning aspect of this. So we'll cover that in one of these last videos on this topic where we start to actually tune and set all this stuff up. But this is the logic and how it works. Okay, last topic, something called dash pot. So what dash pot is when you're not at idle, so you're driving the car. So let's say you're cruising along at 2,500 RPMs. You're just cruising down the highway for 10 minutes, whatever. Well, there's always some air coming through your idle air valve at all times. And in fact, if we go back up here and look at this, we know that when you're in these higher RPMs, it's actually opened up almost all the way because the max was 2.35 pounds a minute at 100% duty cycle. So it's actually, when you're cruising at 2,500, your idle air valve's open pretty far. It's opened almost all the way. So the question is, well, so let's say I'm cruising at 2,500 and now it's time to get off the highway. I clutch it, I let out. Well, you don't want your idle RPMs to just drop immediately and take all the airflow out of this idle air valve or else the car would die. So it has to gracefully pull back from whatever position it was at while you were in the throttle and driving until it gets down to idle. And it uses something called dash pot. So dash pot is basically extra air coming through the idle air valve when you're not stopped and not when you're not actually at idle and you're still driving and moving. And it starts to decay and pull back on that idle air valve slowly so it can give you a nice steady drop until it gets to its neutral state. So this is exactly what your dash pot's here for. So the dash pot is saying that what's the maximum amount of air that I'd want to put in. This is something we usually end up raising up in the higher RPMs of coasting. And this is important to set later. We'll talk about how to really dial that in. And then this is a decay rate. So you're saying if my dash pot is at this pounds per minute at any given time, how fast do I want it to go down? And this is basically the rate at which it's going to lower and work its way down through. So you'll notice that when you're at the higher dash pot and letting a lot of air through because you've just recently gotten off the gas, the rate is going to drop down pretty fast because it's trying to get back to a neutral state. But then as you start to have less airflow going through that, you notice that this pound per minute drop rate starts to get slower and slower. And it does that because if it drops too fast, it'll go under speed, and then you get in that swinging idle and all the stuff we just talked about. So it starts off dropping the airflow pretty quick, kind of slows down as it gets to a more steady state, and then it has just a little bit touch extra that it ramps back up here just to get it totally off dash pot and just back into the normal idle air functionality. So I know this was a lot of different stuff to cover, but this is what your idle air valve is actually doing. It's a very, very important part of tuning these Fox bodies, and there's a lot of things you're going to have to log and do in a very particular order and a very particular way to get this dialed in for your combo. And this is something that I sincerely doubt if you ever use a mail order tuner, they are ever going to touch. And if you strap your stuff on a dyno and somebody says they're going to give you a 1 hour dyno tune with a few pulls, they're absolutely not messing with any of this stuff. And this is not the kind of thing that you can just say, hey, what's your combo, guy? Okay, you got this part and that part. Cool, let me just give you some stuff that I know works. There's no such thing on this part as just knowing what works. This is all going to come down to the particulars. How did you get that idle screw? Exactly what your combo is. I mean, there's so many factors here that you have to go through some very specific data logging and troubleshooting to get this set the right way. And it also requires some mechanical changes on the car that they can't even do remotely. So if they're not asking you to do it, they're just kind of letting you down on this part of your tune, and they're just guessing, or they're just not doing it at all. So anyways, that's how your idle air valve works, and appreciate you sticking with me through all that. The last video series for this piece, again, I'm going to show you how to now tune all this stuff. So we'll kind of continue with our mock combo where we're doing like a mild Vortex supercharged build with a 5-speed car, and we're going to start going through everything you need to do now to get your idle happy. So appreciate it, guys. Good luck. Godspeed.